Welcome to another deep dive. And today we're going to be talking about xenon.
Xenon.
Xenon, you probably know it from those like super bright headlights in cars or other lights. But it's got a whole secret life in chemistry and medicine.
It does.
It really does. It's a noble gas, but it's got some strange effects.
Yeah,
Let's talk about that.
What's really interesting about xenon is that, we think of the noble gases as being totally inert.
Right.
They don't react with anything, but xenon breaks that rule.
Really?
It interacts with biological systems.
Wow.
Which is not something that you would expect for an element.
So how does that even work? I mean, I thought like noble gases, they're full. They've got their electrons all lined up. They're
happy.
behavior.
They're stable. Their electron shells are full. That's what makes them so unreactive.
Right.
But xenon is a little bit different.
Okay.
It's larger than the other noble gases, and its outermost electrons are a little bit further away from the nucleus. And that makes them a little bit more susceptible to interactions with other atoms.
So it's not that it's like eager to react. It's just got more...
It's got wiggle room.
Wiggle room. Yeah.
Exactly. Yeah.
Interesting.
Mm.
So it is, I mean, even though we call them inert, there's a spectrum of how reactive they are.
Absolutely. Krypton and radon, for example, have also shown some reactivity, although not to the same extent as xenon.
Wow. So this makes me think like, are there even more things that we could discover about how reactive these...
I think so. I mean, as we delve deeper into, atomic structure and chemical behavior, we might find that things that we thought were absolute are actually a little bit more nuanced.
Yeah.
And that's one of the things that keeps science so exciting.
Exactly.
Yeah.
One of the things that really blew my mind is that xenon can be used as an anesthetic.
Yeah.
You inhale it and poof, you're asleep.
You're out.
Like, how does that...
It's wild, right? It interacts with specific receptors in our brains that affect consciousness.
Okay.
And the way it works is actually very complex, but essentially it alters the way that our brain cells communicate.
So what's really remarkable is how safe it is.
Right.
I mean...
Compared to other anesthetic options.
Yeah, I mean, it's got a really good safety profile.
Yeah, it's eliminated from the body quickly.
Right.
Very minimal side effects, and that's why it's sometimes even used for high-risk patients like babies.
Whoa. So we've got a noble gas that breaks the reactivity rules, can put us to sleep safely, even babies.
It's really amazing.
This is getting weirder and weirder.
It really does highlight how understanding these elements can lead to some really interesting medical advancements.
Okay, so we've got a noble gas that breaks the reactivity rules, puts people to sleep safely. What's next, space travel?
Well, you're not far off.
Really?
Xenon is used in a type of propulsion system called ion propulsion.
Wait a minute. So it's not just lights and anesthesia?
Yep.
Now we're talking space.
Space exploration, yeah.
Wow. Tell me more about that.
Ion propulsion is a fascinating technology. Basically, xenon atoms are ionized, meaning they're given an electrical charge.
Okay.
And these charged xenon ions are then accelerated by an electric field, creating thrust.
So we're shooting charged xenon atoms...
Out the back of the spacecraft.
Out the back of a spacecraft to move it through space.
To propel it through space, yeah.
That's mind-blowing.
Yeah, it's pretty cool.
Is that like science fiction or is that real?
No, that's very real.
Wow.
And it's becoming increasingly important for deep space missions because it's super efficient.
Okay.
Ion propulsion allows for continuous thrust over long periods of time, which is perfect for traveling those vast distances.
It seems like xenon is full of surprises.
It is.
From anesthesia to space travel, who knew that it could be so versatile?
Yeah, it really is a versatile element.
And that's not all. We haven't even talked about xenon's role in medical imaging.
That's right.
It can be used to enhance MRI scans, particularly for visualizing lung function.
Yeah.
You mean we can use xenon to see inside our lungs?
Pretty much.
That's like X-ray vision.
It's not quite X-ray vision, but it's close.
Close enough.
Inhaled xenon acts as a contrast agent in MRI scans.
Okay.
It distributes to the lungs and it alters the magnetic properties of the tissues.
Got it.
And this allows doctors to see airflow and gas exchange in a way that wouldn't be possible with traditional MRI.
So it helps us see something that we couldn't otherwise see.
Exactly. Yeah.
It's like unlocking a secret window into the human body.
It is.
That's incredible. Okay, so let's not forget about that paradoxical reactivity that we talked about before, where xenon can actually form compounds, even though it's a noble gas.
Yeah.
You mentioned xenon tetrafluoride and xenon trioxide before?
Yes.
Could you elaborate on that a bit?
Absolutely. So Remember how we talked about xenon's outermost electrons being kind of a little bit more loosely held?
Right.
Well, under certain conditions, those electrons can actually participate in bonding with other atoms.
So it's not that xenon's just going to form a bond with anything.
Right. It
That's
takes
just...
special circumstances.
Yeah.
Yeah. It usually involves highly reactive elements like fluorine or oxygen.
Okay.
They have a really strong pull for electrons, enough to kind of entice xenon into forming a bond.
Okay.
So, for example, xenon can react with fluorine gas to form xenon tetrafluoride.
Xenon tetrafluoride.
Yeah.
It sounds like something out of a sci-fi movie.
It does, doesn't it?
Yeah.
But it's real, and it really challenges how we think about inert elements. It makes you rethink those categories.
Totally.
Another example is xenon trioxide,
Okay.
which is a powerful oxidizing agent.
Okay. Break that down for me. What does that mean?
So an oxidizing agent is basically like an electron thief.
Okay.
It steals electrons from other substances during a chemical reaction.
Got it.
And xenon trioxide is particularly good at this, which makes it quite reactive.
Wow. So xenon can form these stable compounds, some of which are even reactive themselves. It's like we're discovering this whole other side to this element.
Absolutely. It's a great reminder that there's always more to discover, even in these seemingly familiar areas of science.
Totally.
It really makes you wonder what other surprises are lurking out there in the periodic table.
I know. I'm starting to see xenon in a whole new light. It's not just about bright lights or putting people to sleep. Yeah. It's this super versatile element with all these remarkable properties.
Yeah, and it really highlights the beauty of chemistry, doesn't it? The way that these elements can interact and form these unexpected compounds, and how these interactions lead to applications that we might never have imagined.
Absolutely.
Yeah.
From the medical field to space exploration, xenon's proven itself.
It has.
What stands out to you most about xenon? What do you think is like the most intriguing aspect?
I think for me, it's how it challenges those preconceived notions,
Yeah.
We tend to think of elements as fitting into these neat little categories.
Right.
But xenon shows us that there's always more to the story.
Totally.
It's paradoxical reactivity. Its ability to form compounds while still being considered a noble gas.
Yeah.
It's a perfect example of that.
That's what makes this deep dive so fascinating.
Yeah.
It's like this reminder that the world of chemistry is full of surprises.
Yeah.
We're really just scratching the surface.
Exactly. And that's what makes science so captivating.
Absolutely.
There's always more to learn, more to uncover, more to question.
Okay, well, I think we've done a really good job of unpacking the many sides of xenon.
I think so.
We've explored its unexpected reactivity, its role in anesthesia, space travel, and medical imaging. We've even delved into the world of xenon compounds. But before we wrap up, I want to leave our listeners with something to ponder. If xenon, an element that we thought we knew, can have all of these, hidden depths and unexpected uses, what other surprises might be waiting to be discovered in the periodic table?
That's a great question to consider. We often take the elements for granted. We see them as these simple building blocks.
Right.
But each element has its own unique story, its own set of properties and potential applications just waiting to be unlocked.
Yeah, it's a humbling reminder that science is an ongoing journey of discovery.
Absolutely.
There's always more to learn, more to explore, and more to be amazed by. Who knows what other seemingly ordinary elements might have these extraordinary secrets?
That's the beauty of it. That's the beauty of scientific exploration. It's about pushing the boundaries of what we know, challenging our assumptions, and being open to the unexpected.
Well said. Well, thank you so much for joining us on this deep dive into the world of xenon.
My pleasure.
It's been a really illuminating journey.
It has been.
And for everyone listening, I hope this inspires you to keep exploring the world around you and to never stop questioning.
Absolutely.
And who knows, maybe one of you will be the one to uncover the next big surprise hidden within the periodic table.
Until next time, keep diving deep.